The LeetCode problem we are going to solve now is called interleaving string. Now this one is a LeetCode medium problem, a very well-liked problem. The thing is, this problem statement is extremely complicated to understand. We are given string s1, s2 and s3. Now we need to check that whether string s3 is formed by interleaving strings s1 and s2. If you want, you can go ahead and read all of this description. If not, let me give you a quick simple example. We can notice that currently the entire S3 can be created using the characters in the same sequence that they are present in S1 and S2. So let's take it one by one. We have this character A. So we can take A from S1. So we use this one. Same way we use A. So we also use this one. Now we have a D. So currently this character is B and this is D. So once again we can use this one. Same way now we have B, B and C. So we can use B, you can use B and we can use C. So same way we use all of these characters, and then once again we have characters B and C, and same way we have character A. So we can take A from here, and then once again we have one more C, and then we can take C from here. And this ends all the characters inside S1 and S2 and all the characters inside the S3. We can say that we can interleave string S3 from the given string S1 and S2. This is what we need to prove for any given input. If we are able to do that, awesome, we need to return true. If we cannot do that, we need to return false. Well, the most basic brute force approach comes to our mind is to check for every single permutation and combination of S1 and S2 to see that how can we form all the characters in such a way that we are able to generate S3. So let's say that we are checking for the first character A. Then we need to either choose the first character over here or first character over here. We cannot choose both. So lucky for us, we can choose A over here. So we get rid of this character. Now we are at second character on B and we are still at first character at B. Now the thing is, next character we are trying to find is B. Let's say that by sheer chance we decided to choose this B character. If we choose this B character, immediately the very next element is X. Thing is, we check, okay, this one is B and this one is C. So X does not match B or C. So we can say that because this does not match either one, we can simply return false, saying that we cannot interleave string. But thing is, this would be a wrong assumption because we did not consider the scenario where instead of picking this B, we could have picked this B, and then we would be still in a position where we are comparing the values between this B and this X, and then this X would have made perfect clear sense. So in the simplest term, we are actually making a decision tree where the very first character option choices we have is amongst A and B, which is the very first these two characters. And for that we have in the S3 we have a character A that we compared. So now we get rid of this one. Now in the next choice we have the characters B and then once again B, and in the S3 once again the character we have is B. The thing is, we don't know which B are we going to choose from. So we can choose from B that is located over here, and then we would have the choices C and B, or we could have chosen this B and then once again the choices we would have is going to be B and X. So depending on that, we can have many different decision trees. And now you will start to notice the problem that could arise, because at every given moment we have the option to select something from between two different tasks or two different paths. And that is the time complexity of 2 to the power n, which is extremely bad time complexity. And that's why solving this problem in brute force would yield the correct result, but this is not going to be a good approach. We are trying to deal a scenario such that any particular result that we are currently calculating is actually going to have an impact on the previously calculated results, and depending on that we will have to make further decisions that which path are we going to take. And this is why this becomes a perfect candidate for the most beautiful concept in the computer science, that is called dynamic programming. Because number one, we will have to keep track that what was the previously calculated result. Number two, what is the current result? And number three, store these values in such a format or such a fashion where we can access them immediately and we can make judgment calls based on that. So let's start understanding with very small examples. Let's say s1 is an empty string, s2 is an empty string, and s3 is an empty string. Once again, yes, from using this example we can create string s1 from s2 and s3. This is always going to be true. Let's take one more complicated example. Let's say the values are going to be a, b, and this value is going to be c. And currently for S3 we are comparing the values A, C and B. We know we can make this one, but how it is going to work? The idea is, first we are going to compare the very first element compared to S1 and S2 and the value S3. And for that, let me just make a very small table. Okay, this is going to say that if I am at 0 and 0th position, then even for the S3 I'm going to check for the 0th value. If I am at first and 0th position, then for the S3 I'm going to check for the first value. If I am at second and 0th position, then 2 plus 0, so I'm going to check for the second value inside the S3, and so on and so forth. We will keep on repeating and compare the values. So let's compare. We know if we are at 0 position and 0 position in S1 and S2, and the cell inside the S3 is also 0, so currently we are starting at 1. 0 means that S1 is empty, S2 is empty, and S3 is empty. In that case, this is always going to be true because we can always interleave string S3 from S1 and S2 if both characters are 0. Okay, that's a given fact. Now let's take this scenario. Currently we are at position A. So let's say that if we are only given S1 is equal to A, we are only given S2 is equal to nothing because we are marking it as 0, and 0 we don't have any value for S2. And for S3 we currently have we are only comparing the 1 plus 0, so we are only comparing the first value inside the S1. So currently S3 also contains just a one value. So if this is the case, are we able to interleave string S3 from S1 and S2? Yes, we can interleave string S3. We can just use this string. So because these two values are same, we can say that this is going to be true. Now let's add one more scenario. Let's add this 2 over here. So if we are given a string such that a, b, s2 is still empty because we are comparing against this cell, and for s3 because this has two characters, we are going to mark two characters. So this is going to be a and c. Now in this case, are we able to interleave string s3 as ac if the given string s1 is ab and s2 is empty? No, because b and c does not match. So in this case we can mark, because they do not match, we will mark this result as false. Okay, if that is, now let's come back. Now we are at this position, so we are checking for this particular cell. So what is the position of this cell? Currently this one is empty, so the value inside the s1 is going to be empty, and the value inside the s2 is only going to be c. And we are comparing the s3 to be so let's do the sum of these characters, because this is 0 and this is 1, so we are only comparing one value from the s3, and that is going to be a. So if we are given three strings s1, s2 and s3 like this, are we able to interleave? No, because this one is a and this one is c, so they do not match, so we are going to mark false over here. Now once again let's repeat the same operation. Now we are checking in for this particular cell. So what are going to be the configurations for the cells s1, s2 and s3? Well, s2 is going to contain character c, s1 is going to contain character a, and for the combination of this one, so this is 1 and this is 1, so 1 plus 1 is 2, so we are going to consider two characters from s3, and that is going to be ac. In this case, we know we are able to generate this pair completely, so we know for sure that this needs to be true. The thing is, how are we able to say for certainty that these pair matches? Well, because notice, and this particular position we have the value, this value as a, this value as c, and the combination of these two values becomes ac. Let's see that what is matching with what. We can see that very first value a, we already have a match because of this particular value, and currently we have a match with c that is coming in. So whenever we have any value on, like this is going to be y axis, So whenever we have any match on, let's say that this is going to be our ith row and this is going to be our jth row. If we have a match on jth row, because C is matching with this current C. So if we have a match on jth row, we will have to compare that are we able to generate A and C in order to make sure that if this C is valid or not. If you get confused, just look at this example and it would make sense, because we can, this character C is only good if we already have a previously matching character. If we did not have a previously matching character, let's say over here, instead of this S3 being ABC, if we had values XCB, then this would have been XC. So even if these two characters match, because we are at this particular cell, still this should not have been true. Why? Because this character did not match, and if this character did not match, this value would have been false. So in this case, because this value was true, so using that, because this value was not X and this value was actually A, then only we can say that there is any fruitfulness in this C currently matching with the subsequent value inside S3. So the result of this character is actually dependent on its previous character, because the string was from S2. So whenever any particular cell from S2 we are trying to compare, we are going to check it with the previous element on top of it. So in this case, we can mark this one as true as well, because this character was true. Same way, now we are at this position where if we notice, this is going to be A, B, C, and since the sum is going to be 2 plus 1, so 2 plus 1 is 3, so we are going to compare all of these three characters. So this is going to be A, C, B as well. Now notice that the matching pair in this case is actually going to be this B. So we are matching with the character from S1. If we are matching for this particular cell for a character from S1, then we need to check that whether the very previous value for all the other remaining S1 characters, are we facing the value to be true. And in this case, because remember, same way for this character, we check that whether this previous element was true or not. And because this element was true, then only we can say for certainty that this has to be true as well. But in this case, now the matching pair is from this region, the top region, then we will have to check that whether for this cell, whether its previous element on the left for S2 was true or not. Why? Because let's say, once again repeating the same example, let's say that if this S3, instead of being ACB, if this value was once again, let's say XCB or XYB, something like this one, then even if this B matches, the previous values did not match. So this value must have been false. So then we would have to mark this false. But since this was not false and we found out a correct match, so we can also mark this as true. Now we iterated every single possibility inside this cell, and same way we simply need to return whatever the value we have at the very last element inside this character, and then we can return it as true or false. Now let's take one more quick example to understand that how does this thing is going to work completely. So for this example, we know that this value is always going to be true, so let's just mark this as true. Now we are going to iterate over the first column. Okay, so we will compare the only S1 values with S3 values. So for this first value, we have a matching. So because it's S1, we are comparing it with its previous value. So currently this matches. So we can also mark this A as true. Same way, next value is B. Once again, AB and AB are still matching. So, and the previous value is true. So we can also mark this one as true. Next value is X and this value is C. Because of this, they do not match. So we are going to mark this as false. We don't need to check any other value. Next value is once again B and this value is D. So once again, they do not match. So we can simply return false. And even if they did match, we would still mark them as false because the previous value was false. Same way, we are going to check the column value where we are only comparing this S2 with this given S3. So currently the very first value should have been A, but over here the value is B. So we can mark this as false. Same way, now this value is B, but this value is X. So once again we can mark this as false. And same way, this value is Y, but this value is X. So once again we can mark this one as X. Now we are at position 1 and 1. So because values are 1 and 1, we are comparing the value number 2. So value number 2 is going to be B. So we can see that yes, there is a potential match B over here. Now notice, whenever there is a match on this side, we will need to compare for this cell, it's above cell above it. So since this value was true, we are going to mark this value as true as well. Now we are comparing once again this particular cell. So for this cell, the value should be 2 plus 1. So we will need to compare the third value. So third value is X over here, and over here both values are B and B. So this value needs to be false. Same way, next we are going to compare 3 plus 1, fourth value. So fourth value is B. So we notice that over here we do find a potential match B with this B, fourth value that we are trying to compare. But the thing is, once again, same way, yes, we have a potential match over here, but the value above this was false. So because of that, we are also going to mark this one as false. And same way, now we have this value C over here, and we have this value comparing between D and B. So it does not match. So we are going to return false over here. Same way, now once again, we are comparing this particular cell. So now the value is 2 plus 1, so 3. So third value is X. Yes, because third value is X, we can notice that this X matches. It matches with the value on, once again, J axis. So we will have to compare the value above it. This value is true. So because of that, this is also going to be true. Then we are going to compare this B and X with this B. So once again, this value is B, that is correct. Now this B matches with the value over here. In this case, because it matches with the value on the I axis, we, for this particular cell, instead of covering the value above it, we are going to check for the value right before it, and this is true. So that's why this is also going to be true. Next, we are going to compare the values between C and X, and this value is 3 plus 2, 5. So fifth value is going to be the C. So once again, this C is true. So if this, because it matches with over here with the ith value, so we are going to compare the value before this one, that is true. So we are going to mark this one as true as well. Same way, the next value we are comparing is going to be D and X, and over here the value is also D. So we are also going to mark this one as true because it matched over here. Now we are at, once again, this position, the value is Y. So the value is 3 plus 1. So 3 plus 1, 4. 4 is not Y. So we can Y, or 4 is not A. So we can simply return false over here. Same way, this value we are comparing is going to be B with Y. So and this is going to be 2 plus 3, 5. So fifth value is actually C over here. So we can return false over here. Same way, now this is going to be 3 plus 3. So sixth value is D, and over here the values we are comparing are going to be Y and C. So once again, it does not match, so we can return false. And the very next value is Y, and because this is the seventh value and we are comparing 4 plus 3, seventh value over here, so we have a potential match Y. The moment we see a potential match Y on this jth axis, then we will have to compare the value above, and the value above is T. So this value is also going to be true, and in the end we need to return whatever the value we found for the very last element. Since this was true, we are going to return true, and this is the whole solution. See how beautiful the solution is, because for every single possible pair, we keep on checking that whether we can interleave string S3 with given subsequent string S1 and S2. So this is pretty awesome. And the time complexity in this case is going to be big O of m multiplied by n, where m is the length of S1 and n is the length of S2. Space complexity is also going to be big O of m multiplied by n, and it is quite obvious because we are using a dynamic programming 2D array to store this answer. So now let's quickly see the coding solution. The coding solution is quite straightforward. First, we are going to define three different variables m, n and l to define respective lengths of S1, S2 and S3 strings. We will check for an edge case that if the given string length m plus n is not equal to l, we can return false immediately. If that is not the case, we will initialize our dynamic programming array, and notice that as part of the length, we are keeping it as m plus 1 and n plus 1. This is to take care of that extra row and extra column where we are only considering S1 or S2 string. Then we are going to have our base case that dp of 0, 0 would be true, as in we can always create or interleave a string with 0 characters if both s1 and s2 has 0 and s3 also has 0 characters. If that is not the case, then we are going to fill in the first row, where we are simply going to check the values for the s1 row, and same way we are going to fill in our first column using s2, where we are simply comparing the characters s1 and s2, s1 with s3 and s2 with s3, and we are going to pick the previous row value or column value in the place of the current ith or jth position. Then we will fill in the rest of the DP table, where we are going to use two for loops starting with I equal to 1 and j equal to 1, and for every single cell we will compare that whether that cell matches with S1 and S3 or it matches with S2 and S3. If it matches with S1 and S3, then we can simply mark the value of the previous row position. If it matches with S2 and S3, the character value, then we will mark it with the previous column position, and based on that we will keep on filling our DP table or dynamic programming table. In the end, we can simply return the value for DP of M and DP of N. So if this is true, it's great. If it is not true, then we can simply return false. And this is the coding solution. Let's try to run our code. Seems like our solution works as expected. Let's submit this code. And our code beats good chunk of other solutions in terms of time complexity, and it is excellent in terms of space complexity. We beat nearly 96.46% of all the cases, which is pretty awesome. And once again, the coding solution is present in our GitHub repository, so feel free to go ahead and check it out from there. Thank you.